Composition of compounds. So the chemical formula, in combination with the molar masses of those constituent elements, gives us the relative quantities of each element in a compound, and that's very useful. Sometimes it's helpful to express the composition of a compound as a mass percent. So this is a useful generic definition of percent. Percent is the part you're interested in divided by the whole thing times 100. So, if you have a classroom that's got 5 girls in it and there's 20 students, right? What's the percentage of girls? Well, it would be 5 divided by the total, which is 20 times 100. I should be able to do that in my head, but my head's not working. 25. Here, where we're talking about mass percent composition, we're looking at the mass of an element, that's the part, divided by the compound's mass. So you can do this from the formula of the compound. If you have the formula, what you're going to do is say, well, because the mass percent does not change if you have more substance or not, right? That's what's nice about percentages. They're relative. So they give you a formula and they want a mass percent, and you're like, but what size is the sample? And they're like, it doesn't matter. That means you can choose something that's easy. 1 mole is easy. So we just choose 1 mole, find the mass of element X in 1 mole of the compound, divide by the mass of the whole compound. We can also do this using experimental numbers, experimental data. And we'll be doing this in experiment 3A, where we make zinc iodide. And so you'll have the mass of iodide and the mass of zinc and the mass of the compound. And so you can take the mass of the zinc that actually reacted and divide by the mass of the zinc iodide that you made, and you can get the percent composition. And then it's also going to make you do it from the formula, and hopefully those 2 numbers are pretty close to each other. Acetic acid is the active ingredient in vinegar. Calculate the mass percent composition of oxygen in acetic acid. We should be able to name this. Whoa, that has a lot of elements in it. Well, cover up the hydrogen. Is there oxygen in there? Yeah. It's an oxyanion. That's in the table of oxyanions. It's called acetate. And so you take the 8 and you change it to ic, acetic acid. That was kind of an aside. So we're supposed to calculate the mass composition of oxygen. So the mass percent of oxygen is going to equal the grams of oxygen divided by the grams of the whole thing. Yeah, I can't even. It's not really spelling, is it? They didn't tell us how much acetic acid, so we're just going to choose 1 mole. Okay, so what is the mass of 1 mole of acetic acid? It's the molar mass, right? Well, we have to calculate it. 1.008. We're going to do a lot of calculating of molar masses. 2 times 12.01. 3 times 1.008. And 2 times 16. You could group this hydrogen and that hydrogen together, but you can also not group them together. You'll get, it's the same either way. So 1 mole of acetic acid is 60.052 grams.
52 or 53?
Well, did you use unrounded masses from the periodic table?
Yeah, the only one I changed for mass was my oxygen. I always put 15 right now.
Yeah, I think that's what happened.
Oh.
So, if we're going to talk about significant figures here, we should probably say it has 2 decimal places, because that's what you would get if you just added all those things together. And so my 60.05 and your 60.03 are fine. There's uncertainty in the last digit. We disagree in the last digit, not a problem. Okay, so that is the mass of 1 mole of the compound. What's the mass of oxygen in the compound? Well, we actually don't really have to do much of anything, because it's just this right here.
So 30 multiplied by
Yeah, we're 32.
32.
So instead of looking at the periodic table again and then going back and looking at how many oxygens are in there, if you write it out like this, it's just sitting there waiting for you to pick it out. So there's 32 grams in 60, right? So 32 divided by 60.052 times 100. And I should have 4 significant figures based on the molar masses that I used. And so 53.29%. If you use molar masses that have more decimal places, then this answer may have more significant figures. Remember, 4 sig figs is the minimum number for atomic or molar masses of elements. Never go less than 4. If you want to go more power to you. Any questions?
So like on the exam, like you're gonna have, I'm just curious because I'm wondering if you should like round up, because I use unrounded numbers and I got 53.27. You got 50, so I'm just curious, like is that gonna?
That's a good question. So on an exam, if you used rounded numbers or unrounded numbers, one was 53.29, one's 53.27. So the exam is going to be mostly multiple choice. So if it's multiple choice, I would not try to trick you by putting both of those on there, because it's mean and it's just not right. So if you come up with 53.27 and the closest choice is 53.29, I expect you to have enough knowledge of sig figs to realize that even though they're not exactly the same, I'm not going to choose none of the above, which I also don't like to do. But yeah. If this is a show your work problem, then I will look at the numbers that you used and you'll also be fine. Good question. Anybody else?